Picture actually did feel very appropriate.
Didn't it? Because I was reading it over and over, reading it to myself. And I was like, okay, so this has to, yeah, that's what I felt like. Yeah, I felt like Charlie.
Okay, so we have a lot of people working from home today, so I'm going to review our syllabus addendum that I just posted last week. Remember to put -remote on your name in Zoom if you're not here, so you guys know I'm not talking to you. But help me get this attendance done. The video will be posted right away. On our 250 course, I actually have it set up, shared off my OneDrive, so it's a lot easier to get set up than putting it on YouTube. I'll put it on YouTube eventually. But OneDrive, I can just copy it there and it's there. Let's see what we've got here. Where'd it go? Jackie, click on your icon in Zoom and you can change your name there and put the -remote. And I think you're the only person I see that's on that's not here. Okay, I see a William on Zoom. I'm counting William Hopkins absent because the William on Zoom does not have their last name and does not say remote, so I have no idea if that would be the right person or not. Do it.
So I was looking for chat to flip out. No response.
You are fine. I'm worried about this William person. You put their number like that's gonna help me. Not gonna help. All right, counting them out.
I think it just switched. I don't know when it switched it to.
Oh, look, you fixed it. Boy, sometimes I sure wish I had the brain mind reading powers that students credit me with. I do. Module 6. Oh my goodness, let's get started. We're going to do some normalization. And then we're going to have a unit exam because it's first all this design stuff is in our first unit. So next week that'll be coming out. I'm still kind of working with the Cengage material, trying to figure out how to put together a practice test, but it might just have to be the fly as you go type thing. We'll see. All right, so normalization. That's really what we've been working on all along. So this chapter should be very easy for you guys to understand, but yet the terminology will work really hard to be confusing. So we can look forward to that because remember, we have nothing if we don't have confusing terminology because we can't guarantee that it's hard to get into our field unless we make it super confusing. All right, so the first thing I have for chapter 6, I opened the ebook and I went straight to the section that says key terms because I see in this chapter, they start out with about 7 highlighted key terms in the first paragraph or 2. And so I figure the key terms are going to be pretty important in this chapter. So I was just going to go ahead and try to keep this tab open so that I could look and refer to our key terms. And in the ebook, when you look at the key terms section, most of the key terms are links that at least show you somewhat of a definition. Not all of them, but most of them are. So that's kind of handy when you're going through the material. You know, my daughter being the librarian, if I gripe at her about a book having a lot of terms, she'll say, well, you know, you need to just be prepared to look up every term that you don't understand. Yes, I know, Heather. I will do that. I will look them all up. Chris T, if you want me to call you here, fix your name the way you're supposed to. You guys give him a hint with that because I've said it too many times. My head's going to explode. All right. Try to keep my head from exploding along with yours. Let's see what we've got with chapter 6. First of all, let's get our OneNote documents open. And I'm going to go ahead and create a new tab for chapter 6. And I'll grab the PowerPoint. I have too many Chrome windows open. Let me find it. So they definitely do have a lot of terms in this chapter, but the reason I say that it's going to be something, that's going to be very understandable to you guys is this normalization that they're referring to is a process. And so it's kind of like a process of painting, you know, where we might have to strip off the old paint and then maybe do some sanding and then maybe paint like a primer coat and then maybe paint an outer coat finally. So we have to be aware that we have to go through that entire process from start to finish, or else we won't allocate enough time for the job. We won't allocate enough resources for the job. That's what normalization is a process for us to go through that we've already really been going through to make sure that our data has been designed in the best possible way, that we can get to all the information that we need. So all of the tools that we've seen so far, all of the diagrams, all of the models that we've been doing have been working towards normalization. So we've really been doing that as we go. So you'll find that as you get into these terms, these are things you already know, that you've already done and you already understand. It's just that this is yet another way of going through this process of database design to try to make sure that we don't make any mistakes. RJ was asking about it before class. All of these tools that we're looking at are tools that were developed by different database vendors, different design tool vendors. So they're all a little bit different from each other, but they're all available to the database analyst, administrator that's trying to design. Why do we need all these tools? Because if we make a mistake in the database design, it potentially affects every application in our system. We've got to potentially touch everything to get it fixed. So database design is a very, very important process. If we get it right, or at least right enough as we go through it, then hopefully we won't have to go through any sort of major revisions or changes like that to our system. So it's really, really critical. Oracle has their own set of tools and Microsoft has their own set of tools, and everybody likes to use their own tools. So we're going to see the same terminology. Now, in our Cengage content, if you would go to the main home screen in MindTap, can you guys see this? Download your data files. I want to see if it actually takes us to the right place. It looks like it. We want to go to student data files and let's get the chapter 6 download.
I might be in the wrong place, but mine only gives me chapter 9.
Am I
Data files?
Yeah,
How'd you have this name?
I'm not above reproach on this, so.
You hit the chapter 6.
Yeah.
It doesn't do anything. That's what mine is, the same there. Okay, well luckily I have those files. So let's just do it a different way. I was hoping we wouldn't have to, but we sure can't. I thought we'll all show you so that you can get to them from home if you want to, but you still will be able to. Let's see, what's going to be our easiest way here? Okay, so I've got them here. Let's try this in the chat. Oh, oops. Someone was messaging me. Okay. So it should go to everybody. Do you see that? Construction code.mdb. let's open it. And when you double click on that file to open it, it should open in Microsoft Access. And we haven't used Microsoft Access before, but you're going to really like it because it's a really easy way for us to look at what we have in our database. And let me get this situated so you can see it better. Over here on the side, notice how it's set to tables right now. So these are tables that exist in this Access database that they've created for us. There are several different tables. We have the employee table, a job table, a project table, the assignment table. If we wanted to look at one of the tables, let's look at this data_org_1NF. That's the first one that they use. If I double click on that, that table will open in data sheet view. So it looks just like an Excel spreadsheet, and it's got all of its rows and columns, and it's showing me everything that's in that database. If I wanted to look at the way the table was defined, I could change my view up here where I've got views. I could go to design view, and then I would see all of the different column definitions for that table. As I look down through them, as I move my mouse pointer down through the different columns, down at the bottom of the screen, all of the specific properties for that column are displayed. Up here under view, do that arrow.
Yeah.
And go to design view.
The bottom, the general, and the lookup tabs.
You're not seeing the field properties. Let's see if it's a view option. I guess right up here where it says property sheet. No, that's that other one. I've never seen it not shown. Oh, it just was not showing you. Ask me. All right. So as you move your cursor up and down through the list of the different columns, the properties down there at the bottom will change. You'll see the information for the specific one. So in Access, if you want, you can get super fancy. You can create entire systems using Access. And you can come and you can put like captions and default values for all of your different data fields. And some companies can be really dependent on their Access databases. So remember, when you're working with Access, we're talking about a database that is really, really usable by like 3 to 5 people sharing. But if we get much more than 15 or 20 people, it's not going to be really usable. So that's why Access is not something that we would use in a large corporation. Now, I've had students before that have worked at companies that said that they had databases that had 30 or more users that were successful, but it's not recommended. So Access is great for a small place. And it's also great for us to look at how to define tables and how the different relationships work together. So I'm looking again at the design for this data.org.1NF table. And if I move around a little bit, I can close out of that table design view. If I want to, I could have multiple tables open. So like if I want to look at the data sheet view for the data org table and also for the employee table, I could double click on that and have it open at the same time. I can't see them both though with this view. So I'm going to come over here and click my restore button, the sub on the window levels, and then I should, why I'm not seeing my tabs and my different table views. like only showing me one table at a time. I haven't used Access 2019, whichever one this one is yet. So
It's
it
down
might
at the
be a little
bottom.
different. Is it down at the bottom? There it is. Where? Ah, got it down there somehow, minimized. It's still just only showing me one at a time though.
You basically treat them as separate windows, and you can like shrink and grow them like you would
Yeah.
like file windows.
That's what I'm doing. Just making this weird little table, little window thing that it won't let me resize. All right, so we have our Access database. If I wanted to add more rows to my table, I could just click down at the bottom in my data sheet view and add more data. Can do all sorts of things with Access. We're just going to look at it from the point of view of looking at the tables that we have. Now, if we want to look at the tables that we have in sort of a graphical view, we can do that. On the Database Tools ribbon, if you go to Relationships, you can see kind of a little bit of a data sheet view of your different tables and the relationships they have to each other. Now, you can see right away that you're seeing kind of the diagramming style that you've been shown at one point somewhere, right? So that we have those different styles. Now, if I want to expand out my different blocks, I can for my different entities. If I click on a relationship, I can see the information about it. I could edit relationships, or I can just double click on a relationship and it'll show me that this relationship is between the employee table and the assignment table, and it's based on the emp num. So our emp num is our primary key for our employee and a foreign key in our assignment table. So we can kind of see that relationship in Access as it's built. So those are the main things that we want to use Access for, is this relationships view. And I can close out of it. So be careful to not change any of your relationships. If you were to delete them, you could do that. If you're capable of changing it. Okay, so we have this database here that we're going to look at. Get back to my reading here. I think we have everything ready. Sometimes it takes us a while. We want to look at in this chapter what normalization is. And normalization, as I mentioned, is a process. And it's a process that we go through of analyzing our data. And as we do this, we try to get our design into specific forms or meeting specific guidelines. And this is an iterative process, meaning we'll try to go through it and make some changes and make sure that we're all in first normal form, etc. We'll look at how we move from the lowest levels of normalization to higher levels, because our goal is to get to third normal form. There are higher levels, but we want to get to third level normal form. We'll use the rules of normalization to correct any sort of errors in our table structure or design, and look at situations that require denormalization. Sometimes we've normalized things to such a point that our data isn't accessible. So we might need to pull back on that a little bit. And then we'll use a data modeling checklist to make sure that our entity relationship diagram meets some minimum requirements. So this process of normalization, we've been working all along, we've been working on modeling data. So an example for me at work might be somebody might come to me with an invoice form and say, we need to have some sort of database to gather this information. And I would take that form and look at all of the data elements that are used, determine what kind of entities those elements belong to, and I would be making the lists and the diagrams that you guys have been working on. Then, as I'm going through this process, I'm going to use this normalization process as I go, or maybe as a follow-up at the end. Different companies are going to do it differently, but really normalization is what we've been doing all along. So we have different forms of normalization. First normal form means our design meets a certain set of rules. Second normal form means our design meets another set of rules. And third normal form means it meets yet a third set. So what are those rules? That's what we'll be looking at. So normalization is where we're going to take a look at all of these entities we've created and all of the data items that we've said these entities contain, and make sure that we have things basically in the right place. We don't have things where they don't belong. So along with that, we'll be analyzing the relationships between the attributes and see if we can make any improvements. What we're trying to get out of a goal here is a good design. Just like whenever you're coding a program, you could get the end results a lot of different ways, right? You don't have to all do it the same way. But as we look at different people's styles of coding, we might prefer one way over another way. We might like that design style. That's the same way we'll be looking at things with our database. We want to find the way that works the best, the most well-formed way of presenting our data. So some things that we have to make sure of. Each table represents a single object. In a software program, we're trying to make sure that each function performs only one task, right? That would be our end goal. Well, as a database administrator, we want to make sure each table represents a single subject. We don't want any grades stuck in our student table, because those grades, they might have something to do with that student, but they don't totally represent that student. So normalization helps us see those differences. We want to make sure that each row, column, intersection contains only one value. I don't want to have, oh, this cell contains all of the class codes this student has ever participated in. You've seen things set up that way, right? Where they just make a whole big old list inside this one cell. That's because they shoved some stuff in there that didn't belong. And whenever we're coding or trying to read through that data, that complicates things tremendously, right? So if we can make sure that each cell contains only one value and no groups, that's going to make our design more well-formed. We want to make sure that no data item is unnecessarily stored in more than one table. That can happen to us pretty easily. Some of the tables, some of the designs that you guys have been creating have had many, many tables already. And you can see how if you mislabel the data element, you could end up with the same data element in two places and not realize it. It's actually even possible to end up with the same data element that's named the same in two different tables by accident without realizing it. And so as we go through this normalization process, we try to identify anything like that. We want to make sure that all of the columns or attributes in our table really depend on that primary key, that they really belong to this student or they really belong to this class. And we want to make sure that there's no potential anomalies, that we can't insert a record without having appropriate supporting information for it. As I mentioned, when we go through normalization, we're trying to get everything to third normal form, 3NF. The higher forms are the kinds of things that we might encounter in some sort of scientific facility, but it's not something that we're going to encounter very often in a business environment. as we go through our tables too, we want to focus on one relation at a time. Remember, we can't just look at the whole giant big picture because we'll just be overwhelmed by details. We have to focus in on a given area, cluster group, and see what's going on in there. So we're going to go through a progress here because we want to make sure that we're getting everything. So what are the normal forms? We'll have to add in, I said, a whole bunch of great terminology to be sure we've got it all. But basically, first normal form says we have entities identified, right? So we know we have students and we have classes. Within our entities, we have no repeating groups. So I don't have anything that I say I'm going to handle as an array. Arrays are, that should, anytime we see an array, that should be another table. That just should happen to us automatically, where we're like, can't have an array, have another table. And our primary keys have been identified. That's first normal form. So you guys have done that. I mean, that's something that you were doing at the very beginning. What second normal form? Well, second normal form means I've reached first normal form, so I've got all those rules met. And now I've made sure that I have no partial dependencies. So as we work ahead, we're going to see what that means. And then third normal form means that in addition to reaching second normal form, I also have no transitive dependencies. And again, we'll be looking at that. Now there's some other forms of normal form. The Boyce CAD normal form says every determinant is a candidate key. I told you there would be some syntax there. We'll look at what that means. And then fourth normal form means we've reached third normal form and we have no independent multi-valued dependencies. That one is harder to achieve, but again, we don't usually worry about that in business. So what do those things mean? Let's get through it. First of all, we're trying to make sure that our design reaches the goal of functional dependence. Functional dependence means that an attribute, like in their case, attribute B, is fully functionally dependent on attribute A if each value of A determines one and only one value of B. So let's look at this example. We have a project table, and in our project table, we have project num, and the project number functionally determines the project name. Now, do you see how complicated of a way that is to describe that? All we're saying is that I can't have a project name without a project number. So my project name depends on my project number. It's functionally dependent. Its function only exists in regards to that project number. The next example kind of clarifies a little further. It says a bunch about attribute A and attribute B again, but what it's saying is that every time I find a project number, is the project name going to be the same for that given project number? Yes, it is. So basically, attribute A, my project number, determines the value of attribute B, my project name. So any place in my tables that I have a project number, I could go to my project table to get that name and it would be correct. Does that make sense? There is no place where my project name would be different for project number one. It would always say project number one. Because sometimes I could have some sort of override or something and I would not have this functional dependence. So it's a common thing. It's like logical, right? We understand that. It's just that it's a high level definition. Now, fully functional dependence is, again, they mention a composite key. We have attribute B, and it's functionally dependent on a composite key A, but not on any subset of that composite key. The attribute B is fully functionally dependent on A. So what does that mean? That means that if I have a project and my project assignment oops, I don't know if we're going to be able to see that very well. Should have a picture. Let's see if they have a picture. Let me see.
On Zoom also, I'll be able to see it on the board.
I know. I was thinking it just doesn't show up very good. I thought they had a good picture. They don't. Maybe it's in the book. Sorry, I just want to show you this though. There is such different stuff. There we go. No picture. All right, we'll get to it. Basically, we're saying that if we created a link table to link the project and the employee, and we had an employee assignment to a project, and then on that link table, we added a date, that date field would have fully functional dependence. It is totally dependent on the combination of the project number and the employee as a combination key, because that date only exists in that link table. So we'll see that example here as we go. We need pictures, we get them. Okay, so let's do some converting to first normal form. This will be better for us. First of all, we have our table. This is the table that's in our access database, our data_org_1NF. And this is the one I was referring to a little bit earlier before class started. As I was looking through the material, I was trying to find figure 6.1 in our ebook, and I don't see it. But if I click on that link, it does take me to this full book. And if I look at the full book, it seems to have more content. So if there are pieces that you feel like you're missing like that I've had that feeling some as we've gone through, we might be looking at a little bit of a subset of our full book here in our ebook content. So what is figure 6.1? Well, we have this construction company, and our construction company has a report that they like to keep up to date with what's going on with their jobs. So here's our report. We have some different projects or jobs. We've assigned an ID to each of them, and we've given each of them a name. We have some employees that are responsible or assigned to those projects. And then we have each of the employee names listed. Giant mess right there, huh? Ew. Then, to make things even worse, for each of these employee numbers and employee names that are listed, we have their job class and how much we charge per hour and how many hours they billed to the job. So it just keeps getting worse and worse. So we can tell already this is just a huge nightmare. We couldn't even look at it and figure out what's going on with it, right? Let alone try to use it. So here's our table. We've got this thing. That report that we're looking at is our unnormalized data, where we're just looking at what they've been using. And unfortunately, in a lot of companies, that is what they use on a daily basis. I can't tell you how many times that I've been teaching this class, I've had people say, that's what my mom's company uses, just a bunch of Excel spreadsheets. I have to go in there on the weekends and help them fix things up. And and they try to get people to convert, but people are scared of change. So anyways, let's go to access. We have our database here. And with our data org underscore 1FNF, we see that we have a project, project name, employee number, job class. So we've expanded a little bit from what that report showed, right? Because we see now, we do at least have a row for each employee. So it's not all smushed up in repeating elements like it was in that spreadsheet. So we can see June here is an electrical engineer that charges this much and has worked this many hours on project 15. But June could appear somewhere else, right? The way this is set up. I don't see her. But here, Anne is in a couple of places. I don't know what the star means. I bet it means something. We don't know. That's a good question. But so here's our data. So we're going to get this into first normal form. So we already identified the repeating groups and eliminated them. How did we eliminate them? We put everything into a tabular format. So by taking our employee information and making it to where we have a specific row for each piece of employee information, we've eliminated those repeating groups, right? Because the repeating groups for the project were our employee information. Now, next, identify the primary key. When we look at our project kind of thing here, I'm still seeing a couple of different candidates for primary keys, right? So what do they want us to do? Let's see. This layout is really more than just a cosmetic change, so let's see what they have to say. Even a casual observer will note that project number is not an adequate primary key because the project number doesn't uniquely identify each row. Because project number 15 can identify any one of 5 rows containing employees who work on the project. So it's obviously not right. So what would we have to do? They say we would need to make a key that's a combination of project number and employee number.
That's what I was thinking.
Then we would have a unique combination key for each project and employee. Now that's getting there. Step 3, we want to identify all dependencies. They say that by looking at our combination primary key, we've already identified one dependency, and that is that all of our project items and our employee items are dependent upon that combination key. So all of those values are dependent on or determined by the combination of the project number and the employee number. So as we see, when we get to first normal form, that's a lot better, but we still could have some anomalies, right? Because we know, I mean, we're developers, we look at this right away and we're like, well, your employee table shouldn't be with your project table. You know, I mean, we just hopefully can see that. But as we go through this process, we're not to that point. So we have to be concerned about these primary key dependencies. Does the project number determine the project name? Yes. So that's a good dependency. And we know that the employee number determines the employee name, the job class, and the charges per hour. They say if we looked further, which I don't see just from looking at the data, we'd have to know some things. But they say we can figure out that the charge per hour is based on the job class. So our different employee classifications are going to have different charges. So here's a dependency diagram. Let's take a look at that. These things leave me wanting a little bit more. So see how you feel about them. I have a project number here, and my project name is dependent upon that project number. So that one makes sense, that arrow, right? Now I have an employee number, and on my employee number, my name, job class, and hourly charge are all dependent upon that employee number. I couldn't have these without the employee. It's kind of a way for us to look at it. They wouldn't be relevant. We saw that based on the job class, we can determine how much the charge per hour is. This bar right here at the top is showing us that project number and employee number are our combination key, right? So that's all that one is saying that those two are together. And then when I look at the top part, I'm seeing that all of this other data is dependent upon this combination key. That's what it's showing us up there. So that's an interesting way to show it to us. Notice how they have it in verbiage down below, what kind of information this is showing us. First of all, in first normal form, our primary key becomes our project number and employee number. We have the project name, employee name, job class, charge hours, and hours, all data elements on that table in first normal form. We have partial dependencies where our project name is dependent on the number and our employee information is dependent on the employee number. And we've seen that we have a dependency where the charge hour is dependent upon the job class. Now, let's take a look at this definition here of charge hour, what they're talking about with a transitive dependency. Neither attribute, charge hour or job class, is part of a key. So that means that we could have data anomalies there, right? That's basically what it's saying to me, is that I have these two data elements that are hidden inside this entity that are not dependent upon any part of that entity. They're transitive because they should be transferred someplace else, right? Because they really don't belong in this entity. Their data is not dependent upon the employee number or the project number, right? So we see them as transitive. We need to refer to that information to build our report, but it's not information that is dependent upon the employee or the job code. Does that make sense? It's kind of an in-between, a gray area. It's like a lookup piece of information that we need to be able to go find, but it's not information that is dependent upon our employee or our job. So our first normal form, it looks like we have a table, right? We can bring it up in Access. It all works, right? Does it work? We could have some anomalies. Let's see what we have. Update anomalies. Let's check our table. They say that if we change the job class for Annalise Jones, let's check it. Find her. Now I can do some things here in my employee column. I could click this arrow and go down and unselect and just select Annalise Jones. So I would be able to, in Access, make it to where those anomalies were easier to control because I could just really easily filter my data. But notice how she exists out in our database, in our table, more than one time. So we could have slightly different versions of her name. Do we? Right now we're in pretty good shape. They look like they're the same, but we could real easily have something that messes up her name. So we know right away that that's a problem for us. So let's get it to second normal form. So the first step of second normal form is to make new tables to eliminate partial dependencies. So whenever we looked at our earlier table and we decided to make that a composite key, that can be actually a hard part of the normalization process. Because why would I go through the process of making that invalid table when I know that I'm going to need to pull that information out? Well, sometimes we have to go through that process just to make it clear to others. But we know now that looking at those partial dependencies, that our employee information is only dependent upon the employee number, and our project information is only dependent on the project number. So we shouldn't have all of that information in the same table. So they split it up. They create a project num entity or table, an employee num entity or table, and then they create a new table assignment. Let's look at our access database. Do we have all those? I think we do. So let's look first of all at our employee table. In our employee table now, we've moved all of the data elements that are dependent upon the employee number. So we have the employee name and initials and hire date and job code. What about our job or project? I'll look at project. In our project table, we've split it down to where we just have our project number, our project name. What do you think that employee number is? Probably our project leader. So we're going to keep some employee information on our table that's relevant just to that project. And then our assignment table. This is the table that's going to have a composite key, or could, of our project number and employee number. We'll look at our normalization process, but in our normalization process, we decided that we should have an automatically generated primary key so that we could control it. So anytime we have an employee that's assigned to a project, we're going to generate a new assignment row. So we've added some data. Look, we have the hours, how many hours they've charged, but we also have added an assignment date. So some information that is only dependent upon this combination of an employee being assigned to a project. That linkage information. Okay, as we created our new tables, then we moved our columns around and reassigned them, those dependent attributes, to be in the place they should be. We checked those dependencies and we made sure that all of our data elements were dependent upon the key of their table. So that's where this diagram is helpful. Now notice how much clearer it is and easier to look at. We see that our project name is dependent on our project number. Our employee name, job class, and charge hours are dependent upon our employee number. And then our new table, our assignment table, we've added how many hours the employee has worked on this particular project. Before that was included in our main table. Now we're still seeing though this transitive dependency. We haven't done anything with it yet. We may have not even identified it depending on the process we're going through. Okay, so now these tables are in second normal form. We're in first normal form and none of our columns are dependent upon anything except the key field. except for that transitive dependency. We're going to resolve it next. Okay. We're going to eliminate it by creating a new table. And I hope that you were already thinking that we need a job class table where I can say, what is this job class? I'm going to use this table to look at a kind of a lookup table. So we're changing our employee table then to just have job class, and our new job class table or job table will have the job class code and what the hourly charge rate is for that job. So now everything looks all clean. That's why I like the picture RJ posted, because that's what things can look like early on, and we're trying to get it all cleaned up. So we've eliminated that transitive dependency. That job class and charge hour was buried still in our employee table, looking like it belonged there, because part of it did, the job class did. It was just the associated charge part that really didn't belong in our employees. So it can be really easy to miss those kinds of things. So now our nice third normal form database is ready for us to do some final analysis. Where do we need indexes, things like that. We've got it, all of our tables set up. So whenever we're looking at normalization, notice at this point, we're not really super concerned about relationships, are we? We're just looking at each individual table, making sure that all of the columns on the table belong on that table, that we don't have anything misplaced. So that's what normalization is, getting everything to the right place, to the right table. And if you do some reading about it, you can find some really, really in-depth discussions. So we've got to do a little bit further refinement, because our third normal form is giving us really good design as far as all of our columns are concerned. But let's go through and reevaluate our primary keys. We want to make sure that our primary key assignments are appropriate, and any sort of other kinds of dependencies that we must have. So anytime a new employee is entered into the employee table, they have to be assigned a job class. So we want to make sure that we don't have any referential integrity violations. That means we don't want to have any employees with invalid job class codes. A referential integrity issue is where the foreign key refers to an entity that doesn't exist. So we don't want that. As we go through and create our job code table, we could be using the job code or the job class as our primary key, but we're going to use job code because we like to use numeric things, make things happen better for us. We could evaluate then our naming conventions, refine our attribute, atomic attributes. I can't say the atomicity thing. That means, do we have any sub-elements of any of our elements? Whenever we're looking at our employee name, we know we need to split that up into last name, first name, and initial. So that's going to help us there. As we go through at this point, now is our time to identify any new attributes. I've been saying from the very beginning, don't worry too much about all of these attributes. We all know we could go through and spend days making a list of potential columns that could be included on a lot of different entities. Now we're finally ready to really do that. What all kinds of information needs to be added? Is it going to affect our normalization process? It could. We might have to go through and reevaluate these new attributes and make sure that they're in the right place, that they're not affecting some sort of dependency. Again, we might come up with new relationships based on our table changes. We know that we're going to have relationships between employees and assignments, projects and assignments, make sure that we have the relationship information that we need. We're going to refine our primary keys for data granularity. That means the level of detail. So we want to make sure that we're storing data at the lowest possible level. We've seen that in a few of our designs where they ask for a total of information. In our table, we always want to carry like the day's sales or the individual item sales, and we'll summarize that information to give any higher level. But we want the lowest level of granularity. We want every single grain of salt uniquely identified in our database. And then we can combine all those grains of salt to make a pile of salt. But we want to identify every unique individual element. So we want the lowest possible level of granularity that we can. We want to make sure that we're maintaining historical accuracy. This is a really important point. Let's see. How did it work for me? I knew how it happened. I even talked to Mutual of Omaha. But whenever we're looking at dates and changes, in their case, they're talking about the charges per hour change. Do we need to keep track of that historical information? Are old projects going to be billed at that old rate? Are they going to be billed at the new rate? Do we need that old rate to make accurate reports of what happened last year? We always have to be thinking that we might need to keep old information. So my story is when my daughter was born, when I became, when my pre-existing condition started, which is when I became pregnant, right? I worked at Mutual of Omaha. I left Mutual of Omaha and came back to Springfield, and my pre-existing condition ended while I was not employed, but I was paying for COBRA coverage. If you're familiar with that, that means you can pay for continued insurance coverage through your employer when you leave. So I had done that. My daughter was not born yet. Was she an entity in Mutual of Omaha's database yet? No, she wasn't, because she did not exist, right? She was still my pre-existing condition. So when she was born, did she have insurance coverage? It depends on the policy, but I can tell you she did not, because she was not an employee. She was not covered under COBRA. She was a brand new human, a brand new person. They paid. Why did they pay? Because there was a flaw in their database design. And when they put her information in, they didn't have historical information to keep track of the fact that she had no coverage at the time this bill was issued. So they covered her. Now I did, I talked to him, said, hey, I don't think you should have covered her. They were like, you got it. It went through. Don't worry about it. Database flaw. But that's how important those little minor things can be to make sure that stuff doesn't slip through the cracks, because we have to be worried about historical information. If I am charging a customer $50 an hour right now, and in 2 weeks I start charging them $75 an hour, I better have a way to make sure my old information is reported accurately to the federal government for my taxes, as well as my own personal information. So I need to make sure I've got that historical accuracy. Finally, we want to make sure that, where are they say here, our derived attribute, our assignment charge in our table was a result of multiplying the hours by the charge amount. That's not something we want to carry, right? That's not the lowest level of granularity. We don't want to carry a calculated, a derived amount like that in our table. We just need to go recalculate it each time. Again, that means that we have to make sure we've got that historical information built in. No derived attributes. And then we finally have our beautiful completed database. So you have that one you can refer to and look at all those different table rows and see how everything is kind of working on. What else? Surrogate keys. Now there is some information here that they are going to present about different databases and specific pieces of information, but I'm going to let you refer to that on your own because we are way past time to do some time. Okay, let's take a look. There are Quizlet terms. I think that there might be some more terms in our text than what there is between Quizlet and our textbook terms. Notice I keep mentioning those because there are some rough ones this chapter. I'm trying to get back to Canvas. That's where I'm headed. If I can get there. So the critical thinking exercises, there's just like one or two. I'm making sure my instructions show up, so I'm not seeing them. They don't. And of course, my notes are at home. Let's look. I have some notes here. Because there are a lot of problems in this one. And I didn't want you to do them all. I know you'd like to. Number 3, let's do number 3 together. I'll get this thing updated today. I'm sorry, I thought I had it where it would tell you exactly which ones to do. I'll find that. But this one we'll do together. We have an invoice table, and here's the structure that we've been given. So notice that our column headings are kind of like meaningless because we've got to figure that out. So we're going to kind of surmise what this different data is and figure out where it should be. So step A, write the relational schema. Draw its dependency diagram, identify all dependencies, including all partial and transitive dependencies. You can assume that the table does not contain repeating groups and that an invoice number references more than one product. Hint, this table uses a composite primary key. So the first thing that I feel like I need to do is identify what these different columns are. What do you think? How would be a good way to do that? So you want to put it in Excel? Let's try it.
Is it just me or is it to the 90-degree angle?
Do what?
So is it just me or is all the data at a 90-degree angle? It looks like all of what I would call column headings.
Oh, I see what you're saying. No, it's not just you. That's why I was saying they didn't give us column headings. But yeah, they did.
Oh, okay.
They just have it backwards.
Yeah. Columns are rows.
I was just like, no, they didn't even tell us what they are. So let's organize things a little bit better. You want to? So we have INV underscore num and prod underscore num and sale date, and prod label, bend code, bend name, quant sold, and prod price. So I have to turn things, like RJ said, that was transposed to me. Now what I could do, because since I'm using Excel, is I could make a list of these data elements. So I think I'm going to make sheet 1 be my data. And then I'm going to add another sheet. And I'm going to make this be, I don't know, entities. Before I can start creating entities, though, I want to copy those data columns over. So I'm going to highlight all of them and copy. And then on my entities, I'm going to do that paste transpose so that I can have my column names going up and down. So now I sort of have a list in a couple of different ways. Now there's a lot of data here that they gave us. I don't want to type all that in, so we'll just review it as we're looking here. So let's see, draw its dependency diagram and identify all dependencies, including all partial and transitive dependencies. I don't think that we have access to the case tool that they use to draw those little dependency diagrams where they have the different rectangles with the arrows, but we could do something like that pretty easy in Excel, couldn't we? Let's try it. Let's just say if we make a row kind of tall, we'll just say that that's going to be our entity area here. So I'm going to start out. Right now we have all of these entities, or all of these data items are all kind of dependent upon each other, right? So what are they saying our composite key is? They said, oh, you're going to have a composite key. If I look at things, I'm saying here, let's do our first one. In invoice number 211347, I had a product number AA, this is hard to type, -E3422QW, and it was on 1/15/2018 that I sold it. The label said it was a rotary sander. The vendor that I bought it from was 211, and their name was Never Fail Inc. We've sold one for $49.95. So I see some different relationships here and some different things. I see that I'm selling a product. to somebody, and all three of those things are important. Who I sold it to, what the product was, and what the invoice number ended up being for that product sale. All of those things are important. So if I copy all of these columns, I'm going to copy this down a little bit to my fat area. Is my invoice number related to my product number? Can we draw a diagram like that anywhere?
I'm gonna say yes.
Where? Can we do it on Lucid Charts? Do they have that kind of diagram?
I don't remember seeing that.
I don't either. I just am trying to figure out. I guess we could just list them. And try to find this book here for me. Well, they have something here. Let me show you what they have in the instructor's guide, because I'm still not sure what kind of tool we would want to use to create this.
I think you can make that as a step.
Think we can?
Yeah, I think you're just gonna insert shapes and link the lines to the attach points on the shape. Should work out.
Should work. Okay, so they're saying that our composite key would be our invoice number and our product number. So I will make those a different color. And then all the rest of them are, they just have them kind of a blue. So the first line that we need to make, let me insert a line and see if I can. Trying to do spark lines for me. Would Word be better? Where do you insert just a line?
Yeah.
Because all I've got is fancy spark lines.
Yeah, so you put the shape on the insert. Because you might have to go full screen to actually.
I didn't. I mean, you're so good. I'm just like, I just am giving up. Ah, there it is. I'm giving up. I'm giving up. I won't give up. Okay. Don't give up. All right. So I just want a line that doesn't have arrows to go from my invoice number to my product number.
You can, the best line is the one next to the down arrow, because you can maintain, I think it's the shift key,
That one? Okay,
and it'll change directions every time.
cool. I will use it. I will use this one for now since I've got it done. All right, then we can kind of manipulate it. Okay, so our invoice number and product number are being used together as our composite keys. Now, our sale date is the date that we sold something dependent on the product number. No, right? Because we could buy a product on any date, so it's not dependent. So it's just does not matter. But our invoice itself, it does matter. We're concerned about what the date of that invoice was. So let's insert a line there. I'm going to go from invoice number to my sale date. I hate these kind of lines. What do you do? Click?
Yeah, so if you hold with that other line,
Find my line.
Oh yeah, not that one.
I'm just using the drawing tool.
That's what I want.
The one that's right next to the down arrow, if you hold down on it when you click, if you hold down on shift when you click, you can just change directions and it'll go 90 degrees. It's basically used to make weird shaped boxes, but
Yeah. I've always tried to avoid it. Someone that's good at it, take over and show everybody out.
I can try.
Grady, are you on the Zoom session? Can you drive? Yeah, someone drive who can make the
Sharing screen is hard.
arrow tool better work better than me. I'm faltering here.
Okay. Let me. Am I right? Okay. All right, where am I drawing the line?
We want to go from invoice number to sale date because our sale date is dependent upon that invoice number.
And you can put, do we want an arrowhead on that?
Yes, the arrowhead should point to our sale date because that is the field that is dependent. Next, yay! For product description. What is our product description or product label? And actually let's change the name of that column from product label to product description or just PROD description. So we should change it every place, right? Because otherwise we're going to create anomalies in our own normalization diagram. So I can use this tool Go back to your home screen
home screen.
for us. And do you see find and select and do the drop down because we want to replace, it's over way over here.
Oh, okay.
And we want to replace.
Oh,
So,
I
we,
missed what you're saying, okay.
so let's find prod underscore label. And let's replace that with prod underscore description. And we want to replace all, and then that way we don't have to worry about it being that old name somewhere. Now click on your options before you close real quick. And make sure where it says within, it's got set to sheet, do workbook, because we want it to change the one on that other page that we created to replace all. Now just replace all again.
I didn't
Okay.
do anything else.
Oh, okay, good.
Do it all.
That's all right. If we had it in more than one place, we would want to make sure we were getting all of our sheets. Okay, so now we got that column renamed. Why would we rename that? Well, product label, that there's all sorts of things that could be on the label about the product, right? We were really referring to our description, so that's a better name for it. But that description is totally dependent upon our product number. So we want to draw that dependency. So we should go from product number to prod description, and there should be an arrow going to the product description. Mm-hmm.
Top okay?
I don't know. They show that top one being the composite key. Let's do bottom, and we'll just make it a different color line. So we want to go over to our product description. And then we also are saying that our vendor code is related to our product number. Did it draw the arrow for you?
I gotta go back to which, I'm sorry, where else do I need to go?
The vendor code.
Vendor.
Perfect. Now, our vendor name is also only related to that product code. So copy and paste that little line segment, that arrow segment. That's why I don't know how to make them do it. I always just copy and paste the little pieces I have. Okay, and then is the number of products we sold dependent on our product? No. But the price of the product is. So we need one more line going to our product price. It is also dependent upon that product number. Now this is an example of an area where it would be really easy for us to draw this on the board, but it's really complicated for us to do it because we don't have any tools designed purposefully to do it. So great job. Now our quantity sold is dependent on the sale, right? So it would be dependent on the combination of the two keys. So at the top, we should have our line without arrows connecting the invoice number and the product number to show that they're a composite key. And then from that line, we want to show that all of the other columns in our entity are dependent upon that key. So we want the little arrow thingies coming to all of the other columns.
So coming out of the top of that.
Yeah, coming out of the top of that thing. So this is where I disagree with the people of the world that say touch screens aren't important. Because I think that we could draw this a lot easier with a tablet or something like that. So if you have those, that would be better. Jackie, he's just using on the insert shape, he's using the arrowhead that allows the turning. Wow, good job, RJ. And you say you're holding control and clicking to shift click to do each turn. Shift click. I keep trying to control click and get it now on that. Okay, so beautiful. Now, our number or quantity sold, they would like to change the name of that column to num sold. So let's do a replace all on it. Yeah, instead of quantity sold, num sold. Now we do have one transitive dependency that we should document, and that is between our vendor name and our vendor code. Our vendor name is totally dependent upon our vendor code, and those elements are transitive. They are not dependent upon the invoice or upon the products. So we just need a line going from vendor code to vendor name with the arrow pointing into the vendor name because it's the dependent column.
Does it matter? Do we put that on top? Can we put that inside of the other one?
They have it inside of the other ones on the bottom. I'm not seeing anything that says it's necessary, but it looks like they've developed a kind of standard of only putting the data elements that are dependent upon the composite key on the top.
Okay.
But that looks perfect. Okay, so down underneath that, let's put some text. And we're going to put our relational schema. And a schema is just a picture of the whole thing. It's not pieces, just the whole thing. In our relation schema, we want to put, here's what we want there. We're going to show that we are in first normal form. So 1 NF, I know it looks like an I, and then open parenthesis. Our invoice number and product number.
Separate comma.
Yes. And they have both of those underlined. Can we do that in Excel? I think we can. Used to, you couldn't.
Yep.
Yay. Okay, and then after product num, we want comma. And we're going to list all the rest of our elements. And then close parentheses. So our relational schema information is basically the normal form that we're in. And then within parentheses, our key fields and all of the other columns.
We only wanted those two under them, right?
We want all of them.
There we go.
There we go. Beautiful.
Oh, okay.
Oh,
It's highlighted the text that I wanted, and then
he's got it. And what did you do? You just copied and pasted all those column names?
I'm sorry, say that again.
You copied and pasted all those column names? Everybody wants to know.
Oh, no, I just typed.
You typed?
Yeah, I was typing.
Oh, I am against the
I
typing.
guess I probably could have copied it.
No, you're good. Beautiful. Beautiful. Okay. So for B, save your spreadsheet. Let's save this spreadsheet. Module 6, problem 3.
I'm sorry, what, I'm saving it?
Module 6, problem 3. Just a suggestion.
Oh,
Now we're going to do part B. That was part A. That's why I don't want you to start on these problems on your own. Part B, remove all partial dependencies, write the relational schema, and draw the new dependency diagram. They want us to identify the normal forms for each table structure that we created. They do have a note here that says, you can assume that any given product is supplied by a single vendor, but a vendor can supply many products. So we can say that the following dependency exists. For a product number, we would have the product label, product price, vendor code, and vendor name. Okay, so we want to go, I would save sheet 1, rename it, and make it be 1NF for sheet 1, because that's your first normal form.
done.
Now let's go to another sheet. That will be our second normal form. And I think that we should copy that beautiful drawing from our first normal form if possible.
There we go.
My phone is going crazy. Okay, so first of all, we want to remove some of these dependencies, and we see that with our invoice and product number combination keys, that our sale date, or I'm sorry, our number sold is the only column that is dependent upon the sorry, I'm trying to see what they want here for part B. They handily combined it all. They say, we've got this all fixed for you. So let's see what we're going to have for this. For our product number, let's pull it out first. We saw that for our product number, the things that are dependent upon our product number, our dependencies are our product description, our vendor code, our vendor name, and our product price. So let's create a dependency diagram that has those. Product num, so we want it.
Yank it out like, I'm sorry, yank it out like that.
Yeah, that's fine, I think. And so for our product number, we want product description and vendor code and vendor name and our product price. Perfect. Look, that really works good because now we can kind of see what's left over. Let's add our arrows. We need the set that shows that all of these are dependent upon our product number.
That goes at the top.
Yes. Beautiful. Awesome. Now within that relationship, we still have that transitive dependency between the vendor code and the vendor name. So let's put those on the bottom and we can just copy that or drag that thing down there because that's where it goes. So it still exists. So it's between our vendor code and our vendor name. Beautiful. So let's put our relational schema information under that. So we want it to say relational schema. So under our diagram. And this time, instead of saying 1 NF, we're going to say 2 NF because we're in second normal form. We've eliminated those dependencies. And our product num is our key. So that would be our underlined data element.
Copying and pasting good work.
Good enough. And then we have
And then we just type in the rest of
the rest of our data elements. Beautiful. And I'm just guessing, but I think these examples we're looking at in the book were done in Excel. So if you find a better tool, share. Okay, beautiful. So that gives us our product information. We have some leftover fields up there, which is perfect. That shows us that we need to create some additional entities. So
now, would we re-wicker that at the top, or do we delete that as not?
let's finish and let's put our other ones beside and below that one you have, and then we'll just delete out all those empty cells after you've moved everything out of the way.
Okay.
That makes sense. So first of all, for our invoice, we know that we have the number that was sold. And the date. But our num sold is really still dependent on our product. So we need to create another entity. Our invoice number should only have the sale date. So those two should be the only things on that entity right now. Just invoice num and sale date. And our sale date is dependent upon our invoice number. So those are the only arrow that we need.
That would be on the top.
Yes. Top dependencies primary key. Beautiful. Now that leaves us that num sold. The only way we can properly identify our num sold is if we use our combination key of invoice number and product number. So for that num sold little data element, we're gonna have to create another entity that has that combination key. So our num sold needs the product num and the invoice num. And we want our product number first because I'm OCD like that. And because we could have one product that gets sold in many invoices. So we want that primariest key to come first. Beautiful. Now let's do our relational schema for each of those. Oh, I'm sorry, you're still arrowing. So we can get rid of this relational schema that was our first normal form. And let's put in our information for our new ones. So we've got the one. So we want to.
You want it right in that area right there?
Yeah, that's perfect. That's fine. So let's say relational schema. She went up. And then our invoice num is our primary key. And our sale date is our only column on there. And then we want to do the same thing for that invoice item kind of entity that we're developing. And then save that. Hang on to this beauty, because we have our guest speakers next time. So we should have some time to finish up after they're done. But if we don't worry, we'll adjust dates and do whatever we need to do to get everything all fit in. So we'll get this one done. Now, as far as the other problems for this chapter, there will be one other one that I'll ask you guys to do with your group. You can work on the, what do they call those other things now? I've forgotten. What is it called? The challenge thing. Because there's only like one of them. But don't worry about any of those other problems. So just be reading through, you know, kind of looking at access, thinking about the things, getting everything finished up. And we'll have our guest speakers next time. That's what we want to focus on. And then we'll continue on and get this one done. Sure, Isaac, that'd be fine. All right, we are out of time. Good job.
So that was problem 3 and 4, right?
That is just problem 3. So don't do any more of them. Yes.
Okay, so just work on the critical thinking.
That's the word. Thank you so much, Kelsey. Yes, my critically deficient brain lost those. Like, what is that for column? Great job. You guys aren't going to know what to do if you don't have to create 50 diagrams every chapter. Okay.